remain at the top of the field view and
evaporation. B. Recrystallization.
Hi, I'm Wisdom Richman. Welcome to Wisdom Analysis, a place where we make chemistry easy and fun. So if you are new here, please do well to subscribe so you can follow on the Jamb series. Alright, let's get straight into the video. So in topic 1 of your Jamb syllabus, you have pure and impure substances, we have the boiling and the melting point, we have element, mixture and compound, chemical and physical changes, and finally the separation processes. So in this tutorial, we're going to just go right from the first one until the end. So it's a full course on just topic 1, and subsequent videos will be discussing further topics, and also try to follow up the past questions that I'll be leaving on the shorts on your short feed. So try to check them out too. All right, let's get started. So what are pure substances? Pure substances are materials that have fixed composition and fixed properties. What do I mean? A pure substance is only pure if it is fixed, it doesn't change. Alright, so water, you know that water is H2O. So that's H2O. Once it changes to H3O, it is no longer water. It has a fixed composition. And now pure substances can only be an element or a compound. An element is a pure substance that cannot be decomposed into any simpler pure substance. That means an element is a pure substance that you cannot break down into another smaller pure substance. You cannot break down an element to produce any smaller element. So elements are seen like the units of pure substances. Then the next one is a compound. A compound is a pure substance that is formed by a fixed composition of elements. That is like the water I used in the explanation. That is a fixed composition of elements, 2 atoms of hydrogen and 1 atom of oxygen, making the water molecule. So if there's any altering of the change, it is no longer a compound. Now, impure substances is just a pure substance that is added with an impurity. So once you add an impurity to a pure substance, it becomes an impure substance. When you hear pure and impure substances in chemistry, it is not necessarily the water was clean and now it's dirty. No, it is about, has this composition been affected, or has this is this water polluted? Is this water polluted? Now don't get me wrong, if you add hydrogen, the hydrogen ion, to the water and you get oxonium ion, which is H3O, that is an ion. It is not necessarily an impure substance because there is a chemical reaction in the process. So impure substances is when an impurity comes together with a compound or an element mixed together. But if they go into a chemical reaction, they form another compound, which is a pure substance. But if they don't go into a chemical reaction, they are only mixed, they form a mixture. Now, for us to understand this well, we need to know the difference between an element, a mixture, and a compound. Like now, let me give an example: salt and water. Now, let's say water is the pure substance. Now when we add salt, it does not form a chemical reaction that leads to a different compound. That's why you still call it salt and water solution, because it has not formed a new compound. So all solutions are mixtures, they are all impure substances. But if any two things come together and they form a chemical reaction, they form a compound, which is another new pure substance. Hope I'm able to get the point across. All right, so now let's go to the next deal on the table, which is boiling and melting points. You should know that pure substances, like we explained earlier, they have fixed composition and they have what? Fixed properties. So this will help you in knowing the understanding of boiling and melting points and how they work with pure and impure substances. Now, since we said they have fixed properties, a pure substance has a fixed boiling and a melting point. They have fixed boiling point and they have fixed melting points too. But when you add an impurity, That impurity can be another compound or another element which is mixed with it, although they are not chemically reacting. So that one has its own boiling point. So when they mix together, there will be two different boiling points. I hope you get the point. That's why mixtures or impure substances do not have fixed boiling points. So generally, if you add impurities into a pure substance, it lowers the melting point but increases the boiling point. Now let's move over to elements, mixture, and compound. Well, there's nothing more to say on this again. We have already explained it as we're explaining the pure and impure substances. But let me just put little things together. Now let's just go to the differences between a compound and a mixture, since element is quite clear. So what are the differences between a compound and a mixture? A mixture can be homogeneous or heterogeneous, but a compound is only homogeneous. What do I mean? Homogeneous means the materials that form that substance, they are like they are in the same state. Let's say we have three states, the three physical states: solid, liquid, and gas. Now, homogeneous means these substances that come to form this substance, they are all in water, or they are all in the gas phase, or they are all in the solid phase. So a compound can only be in one state. You have not seen any compound with two states. Once they have two states, it is a mixture. That is why the impurity can be in one phase and the main pure substance in another phase. But mixtures can either be homogeneous or heterogeneous. That is, they can either be in one phase or in different phases. Now, the second difference between a mixture and a compound is that a mixture is not combined by a chemical reaction. So it can be separated by physical means, while a chemical compound is formed by chemical reaction, so it cannot be separated by physical means. So the third difference between a mixture and a compound is this: a mixture cannot be represented by a chemical formula. That is why your garri and water cannot be represented by a chemical formula, because it is a mixture. The reason why a mixture cannot be represented by a chemical formula is because it does not have a fixed ratio. So in your garri and your water, like I use as a sample of a mixture, the water can be higher than the garri can be higher than the water sometimes, but it's still garri and water. So it does not have a fixed composition. But in your compound, on the other hand, hydrogen has to be two atoms, oxygen has to be just one atom to come together to form that one water molecule. So that's why you see that a compound has fixed ratios, and that's why it has a chemical formula. Now, the next difference I will give is that when you are forming mixtures, there is no great heat change. No great heat change occurs when you are putting a mixture together. Like, you don't just put your water into your garri and then smoke started coming out and your everything just getting hot. No. Once you see that you are mixing two things and it starts forming heat or it starts getting cold, it means that a chemical reaction is occurring, and that is no longer just a mixture. Now let's go to the chemical and physical changes. The chemical and physical changes. Now, what is a chemical change? Okay, from the basic definition, I'm just going to give basic definitions. A chemical change is a change that is not easily reversible, while a physical change is a change that is easily reversible. So quickly, let's go to their differences so we'll be able to spot their properties from there. Number one, no a chemical change, new substances are formed, but in a physical change, no new substances are formed. Number two, in a physical change, it is easily reversible, but in a chemical change, it is not easily reversible. That does not mean chemical reactions or chemical changes cannot be reversed. You have heard of reversible reactions before, right? Yes, but that one is either reversed by addition of heat or one system or the other. But in a physical change, it is easily reversible. I'm not saying chemical changes are not reversible, but just that they are not easily reversible as that of a physical change. Okay, so now let's move over to the next difference. In a physical change, there is no change in mass, But in a chemical change, there is change in the mass. Okay, there is change in the mass when you are forming. In a physical change, there's no change in mass, but in a chemical change, there is change in the mass. Now, the next is in a physical change, no great heat changes occur when you are forming it, but in a chemical change, great heat changes might occur. All right, so now that we are done with the chemical and physical change, without wasting any of your time, let's go straight into the separation processes. So the first separation process I have on my list is sieving. Now, sieving is when when you are making your garri, that process of, it's just what they call a filter something. That's actually a sieve in which they put the garri or whatever on top of it, and the little particles fall out while the larger particles remain at the top. That is called sieving. Sieving is a separation process that separates materials by size, and those holes that the smaller particles fall out is called meshes. They are called meshes. That is the pores or the mesh of that sieve. Now the next on my list is decantation. Now, sorry, I'm going to bring your garri again. When you are making garri to drink, what do? After putting the water into the garri and some of the whatever, those particles that are floating at the top, you carefully pour them out so that you can have a cleaner garri to drink. That process of carefully pouring out the water at the top and leaving the solid behind is separating the water from the solid, right? And this is called decantation. Decantation is a process whereby you separate a solid from a liquid, or two substances that are just maybe in two layers, and just pour out the top one. Okay, so that's what is called decantation. The next on my list is evaporation. Evaporation is simply boiling the mixture so that the water goes out and you leave the solid behind. As easy as that. Now the next is filtration. So what is filtration? Filtration is the process by which you use a filter paper or a piece of cloth and pour in the mixture so that you leave the some particles behind, and the soft smooth particle or the liquid pours down. So that liquid that pours down is called the filtrate, and the particles that remain at the top of the filter paper or the cloth is called the residue. All right, so now we move over to distillation. So now, what is distillation? Now, you have been taught in your basic primary school that distillation is used to purify water. So how does that work? The water that is mixed with different impurities, when you boil it, the impurities may not boil together with the water because they may have higher boiling points than the water. So the water evaporates, and the water is then cooled and then let down again to condense into a liquid again, and now you pick that liquid up as a pure one. That is what is called distillation. So the next is fractional distillation. Fractional distillation is just like distillation, but is an advanced method of distillation. Just a distillation process carried out, but with a fractionating colon. Now, how does this work? Now, different substances with different boiling points that are mixed together are heated up at the same time. Now, since they have different boiling points, when it gets to a certain temperature, the substance of that boiling point will evaporate out and distills over, and they collect it. Now, as a higher temperature, another substance will boil and it goes out, and so on and so on, and the different substances are separated at different boiling points. Now the next here is crystallization. Crystallization is just the process in which salts or any crystalline compound is removed from their solutions. Now the solution is their mixture with water or with any form of chemical. How they are removed, that is what is called crystallization. Crystallization is their mixture with water. So how do they get removed? It's just by heating it until all the water goes out, and then you leave the salt to get dry again. So now the next we go to is sublimation. So what is sublimation? Sublimation is the process by which a solid turns into a gas by direct heating. by heating. The process by which a solid turns into a gas directly. You know that for a solid to turn into a gas, it must first be melted into a liquid, then the liquid evaporates into a gas. But when it moves straight from the solid, skipping the liquid to a gas, it is called sublimation. So how is sublimation used to separate things? Now, if a substance that can sublime is mixed with another substance that cannot sublime, if you heat both of them together, definitely that substance that can sublime will go out, leaving this other substance behind. It will go out as a vapor, leaving this other substance behind. So that's how you separate substances that can sublime from the others that cannot. So quick examples of substances that can sublime are iodine, benzoic acid, sulfur, iron 3, chloride, and then we have ammonium chloride. But the ammonium chloride is the most popular, even across the past questions. So the next on our list is precipitation. 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 Now, what is this? Precipitation is the process of separating two things by solution. Now, what do I mean? Like if A can dissolve in water, B cannot dissolve in water, but A and B can dissolve with each other. Now, since they are mixed and I cannot separate them, if I put it into water, A will immediately dissolve into the water, leaving B behind, betraying B to remain at the top, and then we can carefully select it out. This is called precipitation. This is called precipitation. Now, the next year on our list is chromatography. Chromatography separates different materials by their relative speed in which they move when tested with a solvent. What do I mean? Now, in your paper chromatography, like you did in school with ink, like that ink, that paper now is called the absorbent medium. That is, it absorbs the solvent. In other words, it's also called the stationary phase. Now, the solvent is also called the mobile phase because the solvent moves. So when the paper absorbs that water, it moves up. Remember, the solvent can be water, it can be organic solvents too, not just water. So now the water or the organic solvent will now be absorbed up. So it carefully moves up through the paper, and that process of moving up through the paper, if the substances that are involved in that ink can dissolve in that solvent, it moves with it. So the different substances will move at different speeds, which now separates them, forming a spectrum like view, and in that process they are separated. Now there's also gas chromatography, but basically in the secondary school it is paper chromatography that is majorly taught. Separation funnel method. Separation funnel is used to separate two materials that are not mixable, like your petrol, that is your fuel, and water. If you put them together, even if you pour them and you mix them, whatever you do, after some time the petrol will come to the top and the water will come to the bottom. Why? It's because petrol is less dense than water. That is, it is lighter than water, and so the petrol will be at the top and the water at the bottom. So how do we separate it? Remember, this was in a container. You can just take a nail and burst the bottom, and the water in the bottom comes down. Then you take away your petrol. Now, that is how the separation funnel method works. You can see the separation funnel now. You can see that it has a small pipe at the bottom. So when you open that pipe and you see the water has leaked out, then you can cork it so that you can have your petrol separately. Now, the next method of separation is magnetism. Magnetism is used to separate magnetic compounds from non-magnetic compounds. Imagine you have some iron mixed with dust. Now, how do you separate it? If you cannot separate it by physically separating, or it will be tedious, you can just bring a magnet over it and the metallic compounds will go upward and you've separated it. So now that we are done with the lecture, that was very long, but I hope you enjoyed the video. Now we're going to go straight into the past questions. We are going to be solving these past questions one after the other. So because of time, we are going to only treat 5 in this video, but keep but make sure you subscribe and turn on the notification, because I'll be posting shorts on this topic on because I'm posting shorts on this topic, solving past questions across all Jamb years in just 1 minute. Okay, so watch out for that.
In the experiment above, ammonium chloride crystals deposit on the walls of the tube is as a result of A. Evaporation, B. Recrystallization, C. Sublimation, and D. Fractional precipitation. Well, the true answer is sublimation. This is because ammonium chloride can sublime. Which of the following is an example of a chemical change? A. Dissolution of salt in water. B. Rusting of iron. C. Melting of ice. And D. Separating a mixture by distillation. Now, you can see that the answer is B. Rusting of nail, because you cannot easily reverse a rusted nail into the normal one again. A chemical reaction occurred in the process, so it is not a physical change but a chemical change. The normal boiling point of a liquid is defined as A. The temperature at which the vapor pressure equals the atmospheric pressure. B. The temperature at which bubbles begin to form. C. The temperature at which the vapor pressure equals 1 temperature. D. The temperature at which the rate of condensation equals the rate of vaporization. E. The temperature at which the space above the liquid is saturated. Well, the correct answer is A. The temperature at which the vapor pressure equals the atmospheric pressure. This is the correct definition of boiling point. A pure solid usually melts A. Over a wide range of temperature, B. Over a narrow range of temperature, C. At a lower temperature than the impure one, D. At the same temperature as the impure one. The answer is B. Over a narrow range of temperature, because we said earlier that pure substances have fixed boiling and melting points. So the over a narrow range of temperature is more accurate. Chromatography is used to separate components of mixtures which differ in their rates of A. Diffusion, B. Migration, C. Reaction, and D. Sedimentation. Well, the correct answer is B. Migration, because we said earlier that chromatography takes to advantage the relative speeds, that is, the relative movement in the absorbent medium. So the answer is migration, how they migrate.
Now your assignment is go and read for our next topic, that is topic 2 of your Jamb syllabus, and so that in the next video, when we are doing this tutorial again, you can drop your comments, your questions that you had when you were reading, so that we can deal with them. All right, so I think that's all for now. If you are new here, please subscribe and turn on notifications so you don't miss any of my further videos. All right, see you later. Bye bye.